So we are being recorded. Let's have a look at this lesson, which is about, as I said, it's about the hardware, the components that make up a network, how we record what's in the network with network diagrams, and also other documentation that we would have and procedures that we would have to manage our inventory. When we talk about inventory, we're not talking about stuff in a store, we're talking about all of our computer equipment. So this lesson is about components, right? And about any changes that we make. So it's kind of a lot of stuff. Let's see how we go getting through it. I just thought I'd just click to go to the next page. Yes, I did. All right, so TIA, EIA, they have we use their standard, we refer to TIA and EIA when we talk about structured cabling. Mentioned there, structured cabling. Basically, we have a bunch of sort of terms that we use that are TIA, EIA, and we know when we use that term, what type of cable we're using and where we're using it, that type of thing. So a lot of the terms that you'll be see in this particular lesson, they're TIA terms. And so the idea there is that we have a standard that everybody can use. Now it mentions there that there's a hierarchy. The hierarchy refers to things like horizontal and vertical cabling. You may be familiar with that. That's also in the following slides. All right, so here's a network diagram. I don't know what you see on the board. I think the people online are seeing what's up there, I think. So what do we got? A very important point there that is circled by red dots is this thing that we call demarc, or you could call it the demarcation point. Demarcation means like a boundary or border between two different domains. And in this case, either side of the demarc, and when I say this case, it refers generally to all cases of where a campus network is connected to the internet, for example. So in this case, as in our colleges like this as well, we have a demarc point. I could take you, if we had time, we could go down there and I can show you where the demarc point is. I've seen it. Many of the students have seen it because we've done lots of tours down there. But on the end of building 3, they have an entrance facility, we would call it, which with an MDF in it. All these terms will be defined in this lesson or following. So the entrance facility has a demarc point, which is easily identified. It says QTEL on it, which tells us that that was first put in there before QTEL changed its name to Arito. And at that point, everything beyond it, as shown by this blue pipe, that is ISP, which is Internet Service Provider. The Internet Service Provider for us is Arito, and so they own the demarc box, and everything on the outside of that they also own and they also maintain. Whereas everything on the inside of that we own and we maintain. The MDF is, that's kind of like the biggest computer setup that we've got here at the college. It's got its own sort of dedicated air conditioning, its own dedicated sort of power with backup power, including, like a large sort of diesel engine there for backup power. So it's quite the facility. And actually we should try and get a access to it. Now, throughout the college, we've got these things called IDFs, which is an independent data frame, as opposed to the main data frame there. So the main data frame is attached to the demarc, connecting the IDFs, or the independent data frames, or sorry, intermediate data frames with the MDF is the backbone. And we would see that cabling, that would be fiber optic cabling at our college. Generally, you have to have a high bandwidth cable to do that because it's carrying a high bandwidth of communication. So now the IDFs in this college, each building has, and so here in building 10, down at the end there, actually just underneath where, so actually it's not underneath, it's just at the end where the college instructors rooms are. There's a little room there that has IDF facility. Likewise, in most of the classrooms, but I don't see it in this, we have little telecommunications cabinets. And that they then connect to the IDF, which then connects to the MDF. So that's our network. So we have these terms, and I mentioned a minute ago, horizontal and vertical cabling. Your horizontal cabling is going to connect to your various hosts. Now we have these terms hosts and nodes. So a host is going to be your individual computers sitting out there on the network. On the other hand, our nodes are going to be our devices like our switches and our routers, things like that. So the individual hosts are going to be connected to some kind of wiring cabinet or whatever using horizontal cabling. You're going to use to the main distribution frame, you are going to use your vertical cabling. So our vertical cabling is going to be used, that's our backbone. So think of it that way. Think of your vertical as your backbone and your horizontal as your horizontal is just going to be using Ethernet cable. Ooh, went too fast. So we have data rooms. Now, mentioned a minute ago was the entrance facility. That's where the DMARC is located. So we only have one of those here on the campus. And the demarcation point is actually, there's a little box there that does that. We have a main distribution frame. We have data rooms that generally are locked, racks within those, and we have this thing called a patch panel. There's something related to a patch panel that will be mentioned as well, but this is enough to suffice that for now. Yeah, okay, let's keep going because I want to go kind of quickly. The thing that you should notice about this is that the physical structure of that network is going to be a star. Okay, so it's based around the star idea. And so we have all kinds of multiple connection devices like routers and switches that make that possible. Here we have a patch panel. There's two sides to a patch panel that you could consider. Here we have the front side of the patch panel, which is going to connect through to various devices in a computer room. And don't show the back side. Oh, okay, never mind. The back side would have other cables connected to other devices like switches, etc. So actually your patch panel is just a way of organizing things. There's no sort of there's no sort of network switching goes on in a patch panel. It's just there to help you to organize things so you don't have to have really long cables going everywhere. So we typically have patch panel in a telecommunications cabinet in a room. So what else we got? Well, VoIP, I'm sure you're familiar with that. You may have to be dealing with something like this in a network, voice over IP. So it's just it's an extra set of networking considerations that you have to have. You need a device which is going to act as a sort of a switch for your VoIP. IDF I've mentioned. Work area. This room would be a work area, and in this room we have multiple wall jacks, which we're going to look at in a second. We connect to the wall jack, and then the wall jack inside the walls. There's a cable that goes back to a patch panel, which then connects to switches, which then connect to our cabling that goes down to the data room, and then to our backbone through there. So this would be an example. This diagram is to show you two different ways of looking at a voice over IP implementation. So in the first one, what we've got is we've got a situation where we've got a digital network that's completely digital, including digital telephony. So we can connect those telephones directly to a switch. And then that switch is connected to a VoIP PBX. And so what we need here is we need some kind of a gateway to connect to the telephone company, which may or may not have analog transmission. In the next one here, what's coming into our system is going to be digital communications, but we've got an analog telephone system inside. So we're going to have a special gateway there that's going to convert that digital over the public network is going to be digital, but inside we've got analog. I'm not sure if you've come across analog systems. They're kind of we use the word legacy there because it's the old way of doing stuff. There's not much of that going on anymore. But you could have a system where the company's been in business for a long time, and they have a analog system, and they want to connect to our more modern telephone network. Again, what we see here, where's the DMARC in this? It says it's got the ISP. The ISP, Internet Service Provider, that's represented by, for example, Rito. So this would be our DMARC, would be there with the ISP, and we see this. This is called an extended think it says there, extended star topology. Why? What makes it extended star topology? Well, you see from the MDF, we've got a star, and then the MDF, some of those connections in that star go out to IDFs, our intermediate distribution frames, and our intermediate distribution frames have stars coming out of them. So that's a star, extended star, stars attached to stars. So this is our wall jack, right? Wall plate, and this is to show you how a voice connector might look different to your data connector. Could be that you're just going to use Rj45 for voice as well. So I do at home. All right, so inside our data rooms, we could have these racks, and the racks come in various configurations. So I hope you can see this. There's at the bottom of this rack, all of these devices there. Those are all networking devices, including a patch panel and some other stuff. But this is a 2-post rack. That is just immediately under the devices. There's 2 posts for each of those columns. Whereas if we look over here, this is what's called a 4-post rack, and it's enclosed. So this is going to give you more security for those devices. It's a more expensive, better sort of setup, but this is fine. Also, 2-post. They actually have a thing called a 6-post as well, which is going to be a little bit more too still. All right, so there's some cables that we need to consider. Patch cables. They're just going to be cables that connect from the patch panel to our switching devices, for example. And on the other end of that, horizontal cabling is kind of related to that. That's connecting the workstations to that patch cable area. Our backbone cabling is going to be from our closets to our data rooms, and from the data rooms to the MDF, as it says, between the MDF and the IDFs. So that's typically going to be much higher bandwidth, and so it's typically going to be your fiber. Backbone and vertical. I'll use them interchangeably, yes. Okay, so what we notice here in these cables, you see we've got cables here that are only 10 meters long. That should be that. So in other words, each of these workstations is plugged into the wall, and they are plugged into the wall because you notice you don't see cables lying on the floor there. So actually, yeah, I can see points where they're plugged in down there, right? So that connection should not be more than 10 meters. And then within the wall, we can have up to 90 meters that will connect to a data room. And then in between those, we got cables going between the different devices in there. So this is a limitation based on the cable. So we're talking about Ethernet cables here, category 5 Ethernet cables. What happens when you get to longer than 100 meters is that you get a little bit of attenuation of the signal. You get too much noise for the amount of signal that's going through. And so that's a bad thing. Again, some more on that cabling in the data room. So here we have a 2-post cabinet, and this is a backbone sort of or vertical connection there, and then a short cable that connects to a patch panel, and then that is connecting to your work area. So these would be Ethernet type connectors here. This could be a fiber. Typically, it would just be Ethernet, but this one here would probably be fiber. UTP could be UTP too. I mean, these are the things that'll be UTP. UTP stands for unshielded twisted pair, as opposed to shielded twisted pair, which is STP, as opposed to fiber. And we can see categories of twisted pair. So this is twisted pair. It is unshielded. So this is UTP, and we have more than one standard there. So we got our basic one here. We've got this one here, which is called plenum. The difference between the plenum and our sort of PVC grade or category 5E, plenum grade or category 5E, the difference between the two is that the plenum grade has a fire resistant covering. The The insulating covering on the plenum grade is fire resistant, or at least if it does burn and melt, it doesn't produce noxious fumes, which cannot be said for the PVC grade. If that burns, it's going to produce noxious fumes. So when we're putting cables underneath the floors or in the roof, we're going to use plenum grade, so it'll be safer in the case of fire, etc. Category 6 is a little bit more fancy, I suppose you could say, and Cat 6, what you notice about it is got a nice little insulating tube in the middle around which the cables are wired. So then the Rj45 connector is the standard connector that we're using with Ethernet. So there's just some things here that some suggestions. Could you call them rules? Yeah, okay. We'd say do this so that you have a better network. All right, so don't give lots of space between the of exposed cable before the termination, because you're going to get crosstalk, etc. Don't exceed the bend radius. So the bend radius is about 4 times the diameter. That means that if you bend it over too tight, then that's going to cause bad data transmission. You're going to get errors. If you're running new cables, before you leave, make sure that the cable, it says there verify continuity. That means check that a signal goes from one end of the cable to the other. Cinch cables loosely. You're using cable ties to bind the cables together. Don't bind them so tight that you see it crimping the plastic surrounds. That'll typically going to give you problems. Protect cables. Don't leave them lying around on the ground. People walk on them. That's going to give you problems. Avoid EMI, electromagnetic interference. So don't stick your cables too close to powered devices. So don't put it next to your microwave. I mean, that'd be, but also your hairdryer, anything that's got a motor in it like that. But also, and computers do too, right? So they got little fans and stuff. So try and keep it away from all of those. Use plenum rated for cables that are going to be, as it says, put away. All right, so pay attention to grounding. Give some space in the cable. I mean, in other words, you don't want tight cables going tightly around corners. So you give a bit of extra so that, so they're saying is, you measure it and then you add a half a meter or a meter or whatever, so that you got a bit of extra space. Use some, pay attention to standards and keep records of everything that you're doing. So here's just some hints. Somebody out there who's listening to me, I don't know who it is, one of you for sure, is one of these really organized people who has different colors for all of their notes and things like that, and labels on their drawers that they put their clothes in and their food in, and you just say one thing, say I want this to them, and they go straight away and pick it out. Those people are the people we're talking about here. We want those people. Those people work nicely in a network environment, right? So they'd be going around and labeling all the cables. They would be going, they would build a little notebook of where all the cables were and what was what. The rest of this topic for the next few slides is all about that. Be that person. If you're not that person, get near to that person and learn how they do it, right? So basically just be organized. It's not rocket science. It's just kind of not easy. We rather watch YouTube videos than go around labeling stuff, I suppose. But, there's some people that actually do rather go around labeling stuff than watching YouTube videos. As I said, we want them. We want to hire them in our network. So point here about the HVAC. HVAC means your AC stands for air conditioning, right? And HV, I guess, stands for your heating. Yeah, so in the United States, that's where this term comes from, I think. But what they'll have is they'll have a big unit somewhere in the house, and it does both air conditioning and heating, and they'll have another unit outside. And we got something like that here, I suppose. So the point is that the heating and air conditioning that you have for, like here we have in this room, that cannot be supporting computer systems. People in computer systems, heating and cooling are not very compatible. Computer needs it a little bit colder, and the more computers you got, the more colder you want to try and get that, because it'll be producing a lot of heat. The humidity is also bad. And so you need to have in your data center rooms or wherever your main computer nodes are, network nodes are, you need to have good ventilation, good air conditioning, and it needs to be more strong than your normal one that you're using for people. So yeah. Here's some stuff about the documentation. That was I was talking about, the very organized person who knows where everything is and everything's labeled. Do that, makes things a lot quicker. There are some hints in this about how to do that, and there are some tools that allow you to do that, right? So we got this Nmap and Nmap, which allow you to sort of build some documentation to make things easier. There is a little exercise in the textbook. I gave you a link this morning on the textbook is there. There's a little exercise about using Draw.io to make a network diagram. And we look at network diagrams a bit here as well. Yeah, command prompt. This is this tool called Nmap. If you do Nmap for a particular thing, you get a report kind of like this, which shows you some information about each particular node in a system. So you do have some tools that help you to do your documentation of your system, besides you having to sort of just keep things in paper. So we can use some diagrams. Cisco is famous for that. They produce a lot of what this diagram is trying to show you is Cisco produced a lot of these nice little symbols, and the symbols are automatically and easily recognized by people. You don't even, if you're talking to somebody who's in networking for a while, they know what each of these symbols mean, right? So this one here, that's a wireless access point. Laptop, web server, file server. You see the servers look similar, but they are slightly different. Switch is a sort of a rectangle with the arrows going out. Router is looks like they say a hockey puck. You guys might not be familiar with a hockey puck, but notice that you got 2 arrows going out, 2 arrows going in. That's a router. Firewall, cloud. Yeah, so these symbols, you need to be able to use these. Now, do you need to draw these yourself? No. You can go to any number of drawing tools, Smart Draw, Visio. We own Visio here at the college, so you can use Visio. It's awesome. It's got all those symbols in it. So there's a lot of diagrams that we would use. We'd use network diagrams. We've got different types of network diagrams, logical and physical. Wiring schematic is very, very useful if we're going to go in and try and find a physical fault in the network. Then we're going to refer back to the wiring diagram, because what that's showing is what cable is connected to what. So that's very useful. A rack diagram showing what devices are connected to what in the network. So this is a wiring diagram or wiring schematic. And basically it's showing this cable is connected to that one. And see, each of these devices is not just random device. They're all labeled and numbered. So as I said, that very organized person is going to go around and put a number with some kind of labeling machine on each of these. They're going to label each of those cables, and then they're going to produce this nice little diagram. And when somebody has a problem, they're going to go, oh, I'm going to go look for this. They'll go to the back of the telecoms cabinet. They'll look in the rack and they'll see the cables. They're all labeled, and they'll be able to say, oh, well, maybe it's this cable because this cable is connected to this computer. They'd be able to see that in their rack because they're very organized. Now, if they weren't very organized, that could take hours, right, to figure it out. You're gonna be out there with your voltmeter, your multimeter, trying to figure out which one is which. Wouldn't be so great. So we're still talking about diagrams here. So some other diagrams, we got some special symbols for those. So these are looking at a sort of a physical devices, and these are standard symbols used in diagrams. So switches look like that, patch panel like that, servers and security appliances, and UPS. UPS stands for uninterruptible power supply. Much more documents, right? So we need to keep lots more documents that we keeping documents in all of our connections, logical and physical, IP addresses. We're going to have somewhere a folder which has all the IP addresses that we've assigned to our network and what rooms those IP addresses are assigned to. If we're using DHCP, which is your dynamic assignment of the IP addresses, we're going to have the ranges of the DHCP that are assigned for each particular part of that network. All of these things we record. All right, the idea here of a system life cycle takes into account that we buy equipment and then eventually we have to retire it. Equipment doesn't stay forever. So the life cycle is we buy it, and then eventually we retire it. And so that has to be recorded as well. Actually, retiring equipment is kind of a big deal from a point of view of security. And what I mean by that is our equipment has all kinds of memory devices on it. and those memory devices often are going to have sensitive material on them. And then what, we're just going to give that computer to somebody else? So, you know, if we're decommissioning equipment, we got to make sure that it's secure. So, you know, we do something with those memory storage devices so that somebody else can't so it's kind of tricky because you could just go and do the delete thing, but there's still an image there. All you do when you delete is you remove the index. And so somebody else can, who's got good IT skills or, you know, forensic IT skills, there's people that learn how to do this and they work in police forces and things like that because they want to find out, they think that you're a criminal. So they'll come into your house and they'll seize your computer. And, you know, when you heard them coming, you started deleting everything, right? And they'll go, oh yeah, no problem. Just take this back to the thing and we can sort of undelete that, you know? So you need to do so before you decommission a device, you need to do a proper thing to not just delete, but, you know, reformat, and even reformatting might not be enough. You know, you're going to need to sort of have a proper tool to what you usually do is you write some rubbish onto it over top of, because anything else is going to leave a sort of a mirror of it, an image of it. So you don't want that. So we've got 10 minutes left, and then I'm going to, I'll stop talking because that's probably long enough to talk. Enough about systems. Okay, tips for labeling. Okay, so I'm not going to go through all of these tips for labeling. It's fairly common sense thing. Basically, don't use everything that's all numbers, and be consistent. If you're labeling things which identify the location of it, usually the location is going to be included in the labeling. So do that from the outside in. Yeah, and yeah, so sometimes you have maybe in your cabinet, there's not enough room to label everything, all the details on there. So you could make a little diagram and stick it to the back of the cabinet, so diagrams can be used to help you with your labeling as well. So here we've got a combination. So this person, what they've done, very nice organized person, is they've used one of those label maker machines. You sort of just type in things and prints out this thing that sticks on. And that would be a good thing. If you're that person, you will be welcome in a network job. You know, you like when you see something, oh, it's not got a label, I'll put a label on it. Awesome, they're gonna love you. So here's some other documents that you might want to keep. So this is talking about business documents, request for a proposal, memorandum of understanding, and statement of work. These are, statement of work is a legal document, right? That basically says, this is what we're gonna do. Memorandum of understanding is sort of semi-legal. If you transfer money between each other, then it's going to be. Request for proposal, that's just putting out there, this is what we want. Okay, now we're getting into some other legal agreements. Service level agreement, you may have heard about this if you did client services course. Service level agreement is legally enforceable, as are these others, master service agreement, master license agreement. So those things need to be carefully considered because, and actually passed on to your legal department, I suppose. Now, when you're going to change things in your network, that needs to be recorded. And sir, I have a question. When will the Dropbox will close? So with the Dropbox, I said that we could do that until the end of today, right? There's not much to do for today's exercise. It's just to prove to me that you have installed on your computer what is it? Packet tracer. Do that and you're good. Okay. Just some things there. Like it talks about different kinds of changes that you might have to make in your network. Basically, there's a lot, if you go through these notes and read them very carefully, you'll see there's a lot of words there about being very careful when you do installs and stuff like that. Basically, actually, it says even when you're taking patches for, don't take things just automatically, do it in a regulated, processed way. And be ready to roll back what you've done. So always have a rollback point so that you can go back to where you were before. So backups, things if you're doing operating system upgrades. If you read the notes on this, they're heavy duty into the caution idea of, don't do things ad hoc Don't make any change unless you've got a rollback position that you can go back to the point where you were before the change was made, because you may have to. And it also goes on a lot. There's about testing things. So you should have like a test bed to do that, maybe a room or somewhere where you can take the big changes that you're going to do and test it out in an environment that's not live, and you can sort of see the changes that are going to happen. And then you can do it on the system itself without allowing users on. Now, a lot of these installations and stuff, they're going to happen during non-working hours. Well, that's better, isn't it? Because you're going to be locking users out of the system while you test the changes, because you don't want live transactions during that time. Now, somebody's going to be saying, well, what if you're a bank or something like that? Oh yeah, they do lock people out for a couple hours once every week. I get SMSs from the bank. They try not to do it too much, and they'll run parallel systems so that they can run it on one thing, test it on one thing, and then switch over. So that's expensive, right? But that gives you an indication of how important their software is. But they'll also do sort of, they'll take parts of the system offline. Okay, what else we got? All changes, nothing should be ad hoc. Everything should be approved. That's what we mean by the proper channels, and it should all be documented. And there should always be a rollback procedure. And so the documentation could be a lot more depending on the organization, because there may be requirements from other parts of the organization. Okay, so then we've got to the summary. My gosh, we did make it to the end of this. So at the start, we talked about all of the network components, and we talked about the cabling. So we talked about our standard in the names that we use. So we talked about vertical cabling, horizontal cabling, right? We talked about MDF, IDF, nodes and hosts. Talked about, remember the DMAC, the demarcation point, and our entrance facility, etc. Data rooms, they're going to have your computers in them. They're going to have their own. When it says this serviced by HVAC, everything in the college is serviced by HVAC, but they're going to have their own. And maybe it will have its own uninterruptible power supply that might even include a diesel engine. That's what we got down there in our MDF main data room. Okay, so we've got lots of different diagrams that you should get yourself familiar with. So logical diagrams, physical diagrams, wiring schematics. There's lots of data that you need to keep if you're going to be working in a network environment. And yeah, there's lots of changes that you could be making, but all of those need to be documented. Hooray, we've finished. So I'm going to stop there for a second. There's one other thing I'm going to say before I stop recording, is that we have quizzes. And so my thought at the moment is, let's do our quiz, our first quiz, which will be on chapter 1, I guess. Look on D2L this weekend. So, I mean, our lesson isn't until Tuesday anyways, right? So I'm thinking that's when we'll do our first quiz, be on Tuesday. So I'm going to